Okay, we're going to finish our Unit 1. This is Unit 1, Solving Absolute Value Equations and Inequalities. So thinking to our absolute value functions that we've learned about in transformations, let's kind of look at this. And I want to tell you this note first. The solution to an absolute value equation is the intersection of the absolute value graph with a horizontal line. So you can see here, I have my absolute value graph and the intersection of this horizontal line, and the intersection is -3, 8, and 2, 8. So my solutions here are -3 and 2, and I'll show you what that looks like algebraically. So here's my example. The absolute value of 2x minus 1 plus 3 equals 8. So let's see, when I plug in to Desmos or to my graph here, y equals the absolute value of 2x plus 1 plus 3, that's this absolute value graph right here. So notice that if we factor out this 2, then it's moved over by 1/2, left 1/2, and up 3. So there my vertex is there. And I have a stretch, right? I have a stretch of 2. So you can kind of see here. And then my y equals 8 is on this other side of the equation, 8. So y equals 8 is this horizontal line here. So the intersection of the absolute value graph and this horizontal line, y equals 8, gives me the solutions of 2 and -3. So I'm basically asking, when y is 8, what can x be? Well, in an absolute value equation, it can possibly be two things. So we're going to look at these solutions and how to find them algebraically. So in other words, when y equals 8, x equals 2, positive 2, or -3. And you can see that here in my points. All right, so just a quick reminder about absolute value. The stuff between the absolute value bars could be positive or negative, but when you take the absolute value, the solution is always positive. For example, the absolute value of 4 is 4. The absolute value of -4 is +4, right? So it's always positive, and it's calculating the distance, right? You're finding the distance from 0 is what absolute value is. All right, let's look at our steps for solving absolute value equations algebraically. There are 4 steps. Isolate the absolute value bars. Write equivalent equations, one positive and one negative. Remember, because one could, whatever's the stuff inside could be positive or negative, so that's why you do that. Solve both equations and check by substituting the values. Let's try some of these, okay? Here's my first example. This is example number 1. It says solve -2 times the absolute value of 4x plus 5 equals -10. All right, so my first step was to isolate my absolute value bars. So I want to think, okay, what is stuck to this stuff inside my absolute value bars? Well, it's -2 and it's being multiplied. So we're going to divide by -2. That cancels those. So I have the absolute value of 4x plus 5 equals +5, because -10 divided by -2 is +5. All right, now my second step, that was step 1, right? Isolate the absolute value bars. Now my second step is to write 2 equivalent equations. So think about this. Whatever's in here could be positive or could be negative, but when we take it out of the absolute value or take the absolute value of it, it's a +5. But I want to know what possible values could it be. So 4x plus 5 could equal +5, or 4x plus 5 could equal -5. So I want to solve for what that is. So we're going to solve. So that's step number 2. Write equivalent equations. Now we're going to solve. So on this one, I'm going to subtract 5. So I have 4x equals 0, divide by 4, and x equals 0, right? So that's one of our solutions that we found. When x equals 0, y equals -10, right? So that's kind of what we're saying. That is what we're saying, not kind of. Now I have 4x equals -10, divide by 4, and x equals -10 over 4. Or reduced is negative 5 halves. So x equals negative 5 halves. So that was my third step, right? I want to solve for x. Now my fourth step was to plug it back in and check. So I'm going to plug in 0 back into my original equation. So I have a negative 2 times the absolute value of 4 times 0 plus 5 equals negative 10. And this one is negative 2 times the absolute value of 4 times negative 5 halves plus 5, close my parentheses there, equals negative 10. All right, don't let that fraction scare you. You'll be okay. 4 times 0 is 0. 0 plus 5 is 5. The absolute value of 5 is 5. So once we take it out of the absolute value bars, it's just being multiplied to that negative 2. So we have a negative 10 equals negative 10. All right, that checks out. That's good. All right, and then 4 times negative 5 over 2, we can multiply straight across. Is 4 times negative 5 is negative 20, divided by 2 is negative 10 plus 5. Bring all my other stuff down. So we have negative 2 times the absolute value of negative 5 equals negative 10. Well, the absolute value of negative 5 is positive 5, right? So once we take it out of the absolute value bars, we're just multiplying. So we have negative 10 equals negative 10. We check out, right? So that was step 4. So we indeed do have 2 solutions there, okay? Let's try another example. Flip to another page. This is example 2. So we have the absolute value of x plus 2 divided by 10 equals 8. So my first step was to isolate the absolute value bars to get whatever's in the absolute value bars on one side of the equal sign. Well, I have this 10 stuck to it. It's being divided. So I'm going to get rid of it by multiplying, okay? So I have x plus 2, the absolute value of x plus 2 equals 8 times 10, which is 80. So that was step 1. Hang on. Okay, so now that was our step 1. Our step 2 was to write equivalent equations. So we have x plus 2, whatever's inside the absolute value bars could equal a positive 80, or x plus 2 could equal a negative 80, right? So we're going to solve for those. Right here, we'll subtract. So we have x equals 78. That is our solution there. And over here, we'll subtract 2 as well. We have x equals negative 82. Right? So that was our step 3, solve for x. Here's our step 4. We got to plug it back in and check because you never know. It could not be a solution. We'll run into some that aren't solutions. So I'm going to plug it back into the original equation. I'm going to plug in both solutions. All right, 78 plus 2 is 80. So we have the absolute value of 80 divided by 10 equals 8. The absolute value of 80 is just 80 divided by 10. 8 equals 8 here. So that checks out. Let's check this one. Negative 82 plus 2 is negative 80. We add right or subtract right. Divided by 10 equals 8. So we have the absolute value of negative 80. And the absolute value of negative 80 is just positive 80, right? Because the absolute value of any number is positive. So 80 divided by 10 is 8 equals 8, and that checks out as well. So that was your step 4. All right. So here's our additional examples. I'm going to show you those additional examples. So go ahead and try those. You can pause the video, try those, and then I'll show you the answers to them. Okay, let's look at these examples here. My first example, we should have gotten 15.2 and 4.8. There's the work if you want to pause and go through that work. Here's number 2. Solution is 16/15 and negative 4/15. Plugging them back in should check out. So don't worry about those fractions. They're okay. And then here's number 3. And notice that here I got a 13/3. If ever you want to clear a fraction from your equation, you can just multiply by the common denominator through all of your terms. And then we get a nice little equation here. So coming to 1/3 and -11/6. So I'm going to check this on the graph, and I want to show you here again how you can do that. So here's our Desmos, and notice that here's my, it's kind of skinny, so I zoomed in at where y equals 15, and my intersection points here are -1.83 and this 0.33, which this is 1/3, and this is that 11/6, -11/6. So they do check out. Good for us, we did it right. All right, and then back to number 4. Number 4 was probably the least amount of steps. 4 and -2 are your solutions. And there's that check work there. And then notice that number 5, we got down to dividing by 5, and we had the absolute value equals a negative number. So this is actually no solution here because the absolute value is always positive. So let's see what that looks like on a graph, because I want to show you that.